Hey everybody, I'm meteorologist Gavin Sandell. Well, the weather we feel down here at Earth's surface is controlled by a high-up conveyor belt called the jet stream. And you hear this a lot in the media and on TV, but it basically is just a fast, narrow current of strong winds that are way above our heads, speaking of 30,000 and even more feet above our heads. And the way that happens, it's caused by temperature differences across Earth. Because remember, when the sun gets its energy off of Earth, it comes at different angles. And on the equator, you can see the angle. It's basically perpendicular with the equator. It's going at a 90-degree angle. That sun is right above the equator. When you're going up further towards the poles, that angle that the light and the energy is coming in is a little bit less than that. You see that obtuse angle right there, greater than 90 degrees. You don't get as much direct sunlight, which makes, obviously, the equator warmer than the poles, especially during those polar winters where the sun isn't even on the poles, making those things really, really cold. So naturally, temperatures that are high will try to go towards temperatures that are colder. You'll have movement going from the equator towards the poles, and in that way, that's how we get the jet streams. And it's enhanced by something that we call the Coriolis effect. And the Coriolis effect, because Earth rotates, the Coriolis effect basically says we're going to rotate you a little bit towards the right side to make things just the way that it is. So these are located about 30,000 to 45,000 feet. And because of the Coriolis effect, that bending of energy, it moves from west to east. And so you see that movement around here. You have some little goes up and goes down over here. But at its strongest, especially in the winter, these jet streams can be really, really fast, well above our heads, over 200 miles per hour. And the way that we get faster jet streams is that tighter gradient between the cooler temperatures and the warmer temperatures down there. So there are two jet streams, like I mentioned. The first one that is closer to our area is the polar jet stream, and that one is typically stronger than the subtropical jet stream down towards the equator because the gradient between the temperature over here is greater than the gradient around here, just because, especially in the winter, things don't really get lit up at all, so there's not as much energy, a bigger gradient. And also, jet streams form what we typically call troughs and ridges, something that we mention on our broadcast a lot. The troughs that dip in the jet stream right here, that's very conducive for low pressure. The ridge up here, conducive for high pressure, the bulge in the jet stream. And typically when we see systems moving across jet streams, they basically are a conveyor belt. They go right up and down and back. So this is something that we follow a lot, and when you're along the jet stream, you have very active storm tracks. That's one of the things that I wanted to mention. If you're along the current, you get more active weather typically. If you're away from it, the weather's not as active. Also, if you're north of it, you're typically much colder. And if you're south, you're warmer. Those big polar air events that we see is usually the jet stream dipping down into areas that don't typically see the polar jet stream, which really brings colder air to our area. Also, this is something that we really look at in depth during winter weather events. Things like ENSO, or the El Nino Southern Oscillation, can change the jet streams little by little position. So this is something that we look at just to see where it is and what places will be impacted by winter weather. And by the way, because it's at 30 to 45,000 feet, the jet stream's altitude the same height as planes fly, which is why flights going east are much quicker than flights traveling west. For Weather 101, I'm Gavin Sandell.